Hello. So this is for my CS 111 extra credit video, and in this video I'm going to explain the RSA concept because it's very important not only for this class but for cryptography in general, and I'm pretty sure it will be on the final as well. So let me just go over an example of how to actually encrypt and decrypt any numbers that you're given. So let's say that our encryption key, which is this, is 25 and 55. And we want to encrypt A, which is equal to 2. So the way we do that is we do 2 to the 23rd power mod 55. And how we do that is we basically use a modulus property so that we could simplify it all the way up till it gets to 8. So we can simplify this 23 to 22 times 2, because 2 to the 22 times 2 is 2 to the 23rd. So that's why you could break it up like that. And if we want, and since we want to simplify the 22 down, we want to cut it in half to make it so we simplify the equation more. We do 2 to the 2 times 11, because that's just how exponents, that's one of the exponent properties. And then, then we get 4 to the 11th power mod 55 times 2 mod 55. And since we want to get, since whenever it's an odd integer to the power of, we want to get rid of it, we do 4 to the 10, and we just times it by this 4 mod 55, which you can see here. And since we want to simplify this again, we do we divide it by 2 by timesing the 4 to the 4 squared. So then we get 4 squared to the 5th power, and then we get 16 to the 5th power. And then since we have another odd integer that we're having to the power of, we do the same thing where we do 16 to the 4th times 16 mod 55, so that it simplifies it once again. Then we just do the same thing once again until we get 256. Then modulus, if you don't already know from the class lecture, is whatever the remainder of. So the remainder of dividing by 55 by 256 is 36. So that's why we have 36 at the end here. And now, since we were left with 36 squared here, we have 126 mod 55 plus all these other mods. And one of the modulus properties is that 2 mod 55 times 4 mod 55, you could times those and then take the modulus of them. You don't have to do the modulus all separately. So 126 divided by 55, the remainder is 31. So we get this. Then we get 31 mod 55, and 16 times 4 times 2 equals 128. Then we take the modulus of that. The remainder of it is what it is when it's divided by 55, and that's 18. Then we get 31 mod 55 times 18 mod 55, and that equals 558 mod 55. And the remainder of 558 when it's divided by 55 is 8. So when we encrypt 2, which is equal to A in this case, because I have it so that the alphabet is like A is equal to 2, B is equal to 3, C is equal to 4, and so on. So now we have it equal to 8. But then we want to decrypt 8 back into A. So don't worry about how I get the decryption key. I'll explain that later. I just want to show you how to decrypt it now. So since we want to decrypt 8, we do 8 to the 7th, because that's our first part of a decryption key, mod 55. Then we do a similar process but it's a lot smaller than this one, because instead of to the 23rd, it's to the 7th power. So now we do 8 times 8 mod 55 to get rid of, so this becomes even to 6. Then we simplify that to 8 to the squared, to be 64, and then 64 mod 55. 55 can only go into it once, and then the remainder of that is 9. And we just do the same process until it comes out to 26 mod 55 times 8 mod 55 times 9 mod 55. And then just like how we did last time, we can multiply them and then take the modulus of them. So that's what we did with the 9 and the 8. And then we modulus 72 divided minus 55 is 17. 26 mod 55 times 17 mod 55. That's 442. And then the remainder, when it's divided by 55, is equal to 2 again. So as you can see, by using an exponent to these encryption powers, and then using the modulus with both 55, we were able to get 2, decrypt it all the way to 8, and then get 2, and encrypt it all the way to 8, and get 8, and decrypt it all the way back to 2. So let's go over how it works. It's actually not too... the main draw of RSA is that the larger the number, it's not in terms of, it's hard to find. It is hard to find like the secret key, and it could take way too long if the numbers that you want to decrypt is big enough. So that's how that works. That's why it's a really big draw of any RSA encryptions. You need to make sure that the computations take a lot longer to compute, so that a person can't just hack it. So here's how it works. We pick 2 prime numbers that make up n of the encryption key. So you could just pick any 2 prime numbers, because we're going to go over how you even pick an E and an N. So how you pick an N is you just get two primes, P and Q. And what we do with P and Q is we times them to get N, which is what we use in both our encryption key and our decryption key. Because remember, the 55 was the same for the encryption key and the decryption key. So now we have P equals 5 and Q equals 11. And then so we just times those together to get N, which N equals 11 times 5 equals 55. Then we need to get 5N. So one way we can find this is that all numbers up to 55 that are coprime of 55, So you would count all the numbers that are coprime of 55. So 1 to 55, count all of those that are coprime with it. And you might be wondering what coprime actually is. It means it has no common factors with 55. So one of the common factors of 55 would be 5. So any number like 5 would not be counted for all the numbers up to 50. All the numbers that are coprime to 55. So it's not the number value itself, it's how many numbers there are up to 55 that are coprime with it. And once again, the explanation is any number that's coprime with 55 has no common factors with 55. So let's say it was let's say our n was 10. The common factors of 10 are 1, 2, 5, and 10, of course. So 20 would not be coprime, but 3 would be coprime, because the only factors of 3 are 1 and 3. And 1 is coprime. One is a factor of everything, so we just don't use that when you calculate coprimes. But a really handy tool, if you don't, because that takes a long time to go, okay, is 1 coprime of 55? Is 2 coprime of 55? Is 3 coprime of 55? That takes a long time. So one of the ways that there's like a nifty little formula you can use to find the 5N for any RSA P and Q, which is the 2 prime numbers. So that's, it's P minus 1 times Q minus 1. And since our P was 5, it comes out to 4. And since our 11 was 10, I mean 11, our Q was 11, it comes out to 10. And that means 4 times 10 equals 40. So that means our 5n is equal to 40. And now, how to pick an E? Well, there could be either only one possible E or a bunch of range of values for E. So E has to be one in between 1 and 5n. And it also has to be coprime with 5n, which means it can't have no common factors. So what's between 1 and 40, which is our 5n in this case? Well, 23. And 23 is not coprime with 40 at all. So that's why we could choose 23 in this case. Now we have to get D, which is what we would use for our encryption, for our decryption key. Because remember, our encryption key is E, comma N, and our decryption key is D, comma N. So how do we find it is that D times E modulus of 5n has to equal 1. So we can basically use this technique, which lists out, we enumerate all of the multiples of 23 and 40 to find the D that fits it, so that when you modulate that, it comes equal to 1. So 23 times 2, 23 times 3, and so on, and 40 times 2, 40 times 3, and so on. And as you can see, the difference between 161 here and 160 is equal to 1, which is just like what we want right here. So now we do 7 times 3 plus negative 4 times 40, which is this 4 right here, equals the 1. And that means, since this method is enumerating all the multiples of 23 and 40, and when this equation is fulfilled, that means we found the correct D value. So that means D is equal to 7. And as you can see before, that's the correct value, because our decryption key is 755, or D comma N. As you can see, the RSA crypto system is as you can see, I went over all the steps in how to encrypt and decrypt letters or numbers with the RSA encryption system, and also how the RSA system works. And it's basically it's taking advantage of the unique properties of primes and coprimes of numbers. And thank you for watching this video.